Okay, let us look at our final question, question 19. And in this question, we are given an expression for the sum when r equal to 1 all the way to 5. And this expression is minus 1 to the r by 3 raised to the r plus 1. So what we're going to do, we're going to write out our first two terms at least. When r takes on the value of 1, the first term will be minus 1 raised to the power 1 by 3 to the 1 plus 1. And when r takes on the value 2, the second term will be minus 1 square 3 to the 2 plus 1, and so on. So there are 5 terms. So this simplifies, this first term simplifies to minus 1 multiplied by 3 square, which is 9. And the second term simplifies to positive 1, minus 1 squared is positive 1 by 3 cube, which is 27. So this becomes minus 9 plus 27, and so on. Okay, so in this series, it resembles a geometric progression. So if we had to find the common ratio r, we'll take T2 minus T1. Now let me convince you that it resembles a geometric progression. Let's look at the third term. The third term will be minus 1 multiplied by 3 to the 3 plus 1. Right, so this will give us minus 9 plus 27. 3 plus 1, that's 3 to the power 4. 3 to the power 4 is 81 by minus 1 is minus 81. Right, so you've seen the massive change in your corresponding, your consecutive, the terms that follow. And you will notice that it is not going up, increasing, or decreasing by a fixed amount, which will make it an arithmetic progression. So it must be a geometric progression in this case, right? So let us determine what is this common ratio. We take the second term, the 27, and we divide it by the first term, which is minus 9, and the common ratio would be minus 3. Let's test it. Minus 9 multiplied by minus 3 gives us plus 27. Plus 27 multiplied by minus 3 gives us minus 81, and so on. So if we need to find out the sum of the first 5 terms, let us go back to what is the formula for the sum of the n terms of a geometric progression, and that is given on your formula page. Let's write it down. The sum of n terms is a open brackets r to the n minus 1 divided by r take away 1. Okay, so we are going to substitute our values. In this geometric series sequence, your first term, a, will be minus 9. That's your first term right here. R, we said, is minus 3. And of course, we are interested in finding when n equals to 5, the first 5 terms right here, up to 5. So S5, when we substitute these values, will look something like this. Minus 9 for A, multiplied by r to the n, which is minus 3, raised to the power n, which is to the 5th power, take away 1, all divided by minus 3 minus 1. Right, so let's work it out. Minus 3 raised to the 5th power. Right, since it's a negative power, the result will be negative. So it will be minus 3 to the 5th power. So this will be minus 3 to the 4th power is 81. And you multiply by another 3 there to get 3 to the 5th power, which will be 243. So this will be minus 243. Right, let's substitute that. So this becomes minus 9 by minus 243 minus 1 all over minus 4. A lot of negative signs, huh? Right, let's simplify what's inside the bracket. That becomes negative 244 divided by minus 4. And this could be divided here. This will give us 61. 61 by 9. 9 is 9. It's a negative quantity. 61 by minus 9. 9 6 are 54. It's a negative quantity for your answer. So your answer will be negative 549. Let's see what that corresponds to. Right, I'm seeing answer D. Answer D. And that brings us to the end of our discussion of our... No, there's one more. There's one more. Question number 20. The sum of the odd integers between 10 and 50. Let's do that. There's one more. Okay. So we want to find the sum of the odd integers between 10 and 50. So let's see if we can set this up. It'll be 10. Let's write down our first few. 10, 11, 12, 13, 14, 15, 16, 17, all the way down to 49, 50, right? Now, we want the sum of the odd integers or the odd numbers. So let's underline those or circle those numbers that we would like to have the values of 11, 13, 15, 17, all the way down to 49. All right, now let's see if we can find the correct formula to use here now. All right, so right, Tn is equal to A plus n minus 1 by D. That will be a useful formula. And then we have the general formula, Sn. I'm using what's on the formula sheet, is n over 2, open bracket, 2A plus n minus 1 by D. Now, we are not given here, unless we write out all the numbers and count them, the number of terms that is odd integers from 11 to 49. Notice we have some missing terms in between here. So unless we state all the terms, then we can count and find out what is the value of n. Alternatively, we can use this formula here because we know the last term is 49. We know the first term is 11. We know the common difference here is going up by 2. So then we should be able to figure out how many terms are there. So when we expand this and simplify, we're going to get 49 equals to 11 plus 2 by n, 2n minus 2. So this gives us 49 equals 11 take away 2 plus 2n. 49 equals 9 plus 2n. 49 minus 9 equals 2n. 40 equals 2n. So n will be 40 divided by 2. N will equal to 20. So there's 20 terms from 11 all the way down to 49. Right. Now that we have worked out what is the n, we can now figure out the sum of these 20 terms by using n as 20 in this formula here. So that will give us 20 divided by 2, open brackets, 2 by our first term, which is 11, plus 20 minus 1 by a common difference, which is 2. So S20 will work out to be 10 multiplied by 22 plus. Now this is 20 minus 1 is 19 by 2, 38. 38 and 22 is 60. 60 by 10 equals 600. So your answer should be 600. Right, let's see which option gives us 600 as the answer there. Right, I'm seeing answer B. So that brings us to the end of our discussion of the solutions for 2017 relating to series. May God continue to bless you until we meet again.